All right, what's going on, everybody? Today we are going to work on the Chapter 5 review. It's just a bunch of example problems to help prepare you for the test. So please make sure you're watching this video and coming to class with any questions because you're taking the Chapter 5 test in the class after that. Okay, just a quick warm-up. Find the value of x. So what we need to do is see that we have two congruent angles here. If we have two congruent angles, that means we have an isosceles triangle, and that means that the opposite sides of those two congruent angles are the congruent sides. This 20 here, honestly, is just something there to confuse you. If these two sides are congruent to each other, we're going to set up our equation of being 9x minus 8 is equal to 28. Okay, and we combine we get rid of the 8, so we add 8 to both sides. Those cancel. We get 9x is equal to 28 plus 8 gives us 36. If we divide both sides by 9, we get x is equal to 4. Okay, so just a nice little warm-up. Okay, from lesson 5. I believe it was 5.2, we need to be able to classify triangles by both their angles and their side lengths. Remember, you need to classify it two different ways. So questions like these, you'll have to give two different answers. If we look at the side lengths here, we see that we have two congruent sides here. So we would name that an isosceles triangle. And by angle, we see have one obtuse angle. So we would name that an isosceles obtuse triangle. Okay, over here, side lengths, it doesn't say anything about the side lengths. It doesn't give us any numbers, but it also doesn't give us any congruency marks. So we're maybe not 100% sure. So let's look at the angles. We see that all of the angles are different. And we also see that all of them are less than 90, which means they are all acute. And since all of the angles are different, meaning none of them are congruent, we can then assume that none of these sides are congruent, which means this is going to be a scalene triangle, scalene acute. Okay, finding the value of x. Remember, all angles of a triangle must add up to 180 degrees. So here, for this one, we would do 35 plus 88 plus x is equal to 180. Combine like terms. 35 plus 88. I'm going to do this here slowly. 5 plus 8 gives us 13. Carry. That's 9 plus 3 gives us 12. So 123 plus x equals 180. Subtract 123 from both sides. And you get x is equal to 180. So we got to borrow. Turn that into 7. 10 minus 3 is 7. 7 minus 2 is 5. 1 minus 1 is nothing. So x is equal to 57. If we change the thing that we need to notice about this one, 10, 10, and 10. All three side lengths are 10, which means that this is an equilateral triangle. And we know that all equilateral triangles, each angle is 60. All right, so we know that this is 60. These two are 60, which means this one is also 60, but it's represented by 5x. So we just do 5x is equal to 60. Divide both sides by 5. And we get x is equal to 12. Okay, moving on. Next, find the value of x still. Exterior angle, remember exterior angles are equal to the opposite two interior angles added together. So this is just x is equal to 21 plus 34 plus 34. So that would mean that x is equal to 55. Okay, again, we see that we have an isosceles triangle. If two angles are congruent, that means these two sides are congruent. And if they're congruent, we set them equal to each other. We would just have 2x minus 1 is equal to x plus 7. Subtract the x from both this side, you get x minus 1 equals 7. Add the 1 on both sides, and you get x is equal to 8. Is it possible to make a triangle with the following side lengths? Remember, if you add together the two small sides, it has to be bigger than the third side. So we add these together. 6 plus 8 gives us 14. Remember, 14 is not bigger than 14. It is the same, so this one is going to be no. Over here, 3 plus 7 gives us 10. 10 is bigger than 9, so that means this one is yes. Describe the third side length for a triangle with the two given sides. Remember, you add together the numbers and you subtract the numbers. So if we subtract 12 and 2, that gives you 10. That would be the lower limit. So this third side length has to be bigger than 10, but it must be less than adding them together. 2 plus 12 gives you 14. So that means the third side length has to be bigger than 10, but smaller than 14. Over here, we subtract 11 minus 8 gives us 3. So that means the third side has to be bigger than 3. And then when we add them together, that means it has to be less than 19. Sorry, 11 plus 8 is 19. Okay, if MP is a mid-segment, find the value of X. Remember, mid-segments are always half the length of the third side. So if this side length is 16, that means X must be half of 16, which means that X is equal to 8. Over here, though, we see that X is on the outside, right? Doesn't have anything to do with the mid-segment, but also remember a mid-segment cuts each side in half. So that means this is cut in half. That means this is cut in half. So if this half here is 4, and this is the other half, X also has to equal 4. Okay, this is from lesson 5.1, the very beginning. Remember, some of this was from before we went away for winter break. Congruency statement is important that you name the congruent sides with the other congruent sides. It has to be corresponding, and the order is important. So since A went first in triangle ABC, we have to find the angle that matches with A, and we see that 2 congruency marks matches with 2 congruency marks, so we would have to name this one D first. B went second, has 1 congruency mark, so E goes second. And then here C has 3 congruency marks, and that matches up with F, which has 3 congruency marks. So that is the proper way of how to finish the congruency statement. They have to match. Okay, decide whether the triangles can be proven congruent. If they can, by which theorem? SSS, SAS, HL, ASA, or AAS. If you cannot prove that they're congruent, then just state that they're not congruent. So let's take a look. Remember, just match up or label congruent sides with S's, label congruent angles with A's. We see that 1 matches 1. We label that with A. 2 bubbles matches 2 bubbles, another angle. And remember, this side here in the middle is used by both triangles, so we would label that with a side, and that is a side. Okay, but remember they have to match, so we count them out. We have AAS, and we see that it does match with AAS, but this was one of our homework examples, and a lot of people ended up missing this because we need to pay special attention. Notice we started with A, that was a single bubble, but over in this triangle, we started with A with a double bubble. So that means, yes, we do have AAS for both of these triangles, but the angles are not corresponding to each other. So therefore, we would say that this one is not congruent. This one was kind of like a trick. Oops, not congruent. That one was kind of tricky. Okay, over here. Remember, whenever you see a right triangle, always check HL first. Opposite from the right angle is the hypotenuse, right? Technically, we don't know if this is a right angle, but we can prove it because it makes a straight line. Straight lines are 180 degrees. 180 minus 90 means that this one also has to be 90. So that means opposite from here is also the hypotenuse. And we see that the two hypotenuses are congruent to each other. And then we see that this line here in the middle has to be congruent because it's the same line. That's our leg. So this one is congruent due to HL. Okay, over here, 1 matches 1. That's a side. That's a side. 2 matches 2. That's a side. That's a side. And 3 matches 3. That's a side. That's a side. Therefore, both of these have SSS, SSS. So therefore, these are congruent due to the SSS theorem. Okay, this one over here, single matches single bubble. Those are angles. 1 tick, those are sides. And double bubble and double bubble, those are angles. But remember, double check. This one we have ASA, But over here we have AAS, so therefore they do not match. ASA does not match with AAS, so therefore these are not congruent. Okay, over here, 1 matches 1, those are sides. 2 matches 2, those are sides. And that's all that the picture gives us. But remember, we're pretty smart and intelligent people. We see that these two here are vertical angles. Vertical angles are always congruent to each other. So even though it doesn't give us the congruency bubbles, we know for a fact that they are congruent. We know that those are congruent angles. So we label that with an A. And we see that SAS does in fact match with SAS. So that's how we know that those are congruent. And one final option. We see that 1 matches 1, that's a side, that's a side. 2 matches 2, that's a side, that's a side. And unfortunately, there's nothing else for us to go off of. There's no vertical angles. The triangles are not sharing the same side. There's really, truly nothing else for us to go off of in this one. So this is just clearly not enough information. Even though they look like they're definitely congruent to each other, there's not enough information. So we have to say that these are not congruent as well. Okay, and then a proof chart. There will be only one proof chart on your test as well. So always take look at your given information. Remember, given is always your first reason. RS is congruent to AT, which we see the congruence lines are already there for us. Good thing. Obviously, if they're not there, please draw all over it. Okay, RA is congruent to ST. RA is congruent to ST. That is also given to us. All right, as you can see, this is a fairly easy proof chart. Yeah. And so we know we have 2 sides. That means we need another angle. We need another side. We need to prove something else in order to know that these are going to be congruent to each other. Well, once again, we have the thing where we have both of these triangles are using the same exact line, right? RT is being used for this triangle and RT is being used for this triangle. So here we would say that segment RT is congruent to segment RT. And remember, the property that says that the same line is congruent to itself, that is always the reflexive property. And we can label this as a third side. Label, we got side, side, 2 matches 2, side, side, and 3 is the same line, so that's side, side. And now we can prove that these 2 triangles are congruent to each other based off of the side, side, side theorem, or SSS. And that's it. Basically everything that you've seen in this video, you can expect to see on the test. A similar example, obviously not the same ones, but also maybe the same ones. So please bring any questions you have to class, study and prepare hard, and let's start off this second semester with a great first test score. Go Mustangs.